Okay, so we're going to talk about inverse functions in this section. One example they give in the book is what's called a reverse heat pump. So you have this like machine, kind of like that, okay, and if it's hot or if it's cold and you want it to, spit out heat into the room, it works one way, but if it's hot and you want to take heat out of the room, it goes another way. All right, so that's like an example of inverses. One of the examples I use is tying your shoes. So, in the morning you tie your shoes or you put on your shoes and you tie them. In the evening, you untie your shoes and you take the shoes off. So, you're back to your bare feet. You're back to where you started. So inverse functions do that. You have to have two of them. They come in pairs, I guess. So here we have another example. It's temperature. So this is, if you want to find the Celsius temperature, but the Fahrenheit temperature, you can use this formula. It's a real formula. So let's say, the temperature is 75 degrees. Okay, so what is it in Fahrenheit? So 75 degrees Fahrenheit, and you want to know what it is Celsius. So you put it in the formula, 5/9. That's going to be 75 minus 32, which is going to be 5/9 times what, 43? And let me just do that on my calculator really quick. I'm going to go 5 times 43 divided by 9, and it's about 24 degrees Celsius. Okay, well, say you're going to go to some place where they use Celsius a lot, and you want to know the Fahrenheit degrees so you know how to pack. Like now okay, 75 degrees Fahrenheit, that's 24 degrees. But let's say, there's going to be several days and you want to know, what kind of clothes you should pack. You're going on a trip or something. And so you want to know a lot of Fahrenheits, but the Celsius. Like you look up the country you're going to and you get the weekly report of the weather and the Celsius temperatures. Now you want to convert it to Fahrenheit. Well, you could do that every time. You could go through this process and take this, the Celsius and figure out the Fahrenheit. But what you could do is rearrange the equation so that it was Fahrenheit equals blah, blah, blah. And we're going to do that later on in another video. But that's the idea of inverses. Like here we are given Fahrenheit, that's our input. And then the output is the Celsius temperature, right? But what if we wanted to go the other way and have the Celsius temperature as the input, and we wanted the Fahrenheit as the output? Okay, so that's all we're saying there. And that's what inverses are. The inputs and the outputs switch. Okay, we do have some notation for inverse. If you have a function f of x, then the inverse notation is f inverse of x. That's how it's read. I know it looks like an exponent, but it's not. It's just a superscript, and it's on a function name. So that would be f inverse of x. In order for a function to have an inverse, it has to be 1-to-1. And not all functions have inverses. So sometimes, you're going to have a function and there just isn't an inverse. Okay, I think that's all the terms we wanted to put in that video.